My name is David Varela, and I'm going to walk you through my final term project presentation. The track I chose was the research track, and I am focusing on AI systems and cognitive load and decision making. The research question I'm aiming to answer is, why does understanding cognitive load and AI assisted decision making matter? And some of the key points in this effort include the cognitive load theory, which uh, assumes that mental resources such as working memory and attention are limited. Properly tuned AI interfaces can reduce complexity and streamline tasks. And the main focus for this project is mainly finance and some educational technology as well. I conducted a systematic review of peer-reviewed papers, searching through academic databases with terms like AI cognitive load and distributed cognition, terms I learned from my human-computer interaction class. I then filtered papers discussing cognitive load and AI optimization, especially in finance and education, and I excluded articles that may have not contributed much to this research study. At the end, at the beginning, the search was broad, and I identified the papers that I was most interested in, and I focused on those. And let's walk through the results now. So first of all, I had an AI interface design and cognitive load finding, which was that well-structured, user-friendly AI dashboards lower cognitive load. The reason this matters is because clutter interfaces force users to allocate excessive cognitive resources to navigation and filtering. Streamlined designs free up working space memory to focus on the decision task. Okay. The second finding is related to distributed cognition. And the finding is that splitting tasks between humans and AI systems effectively reduces cognitive load, allowing each to leverage its strengths. The reason this matters is that in high stakes environments, such as finance, healthcare, and so forth, distributed tasks reduce mistakes linked to human cognitive overload, leading to improved performance and enhanced user satisfaction. The next finding is transparency and explainability. When AI systems provide clear, accessible reasoning for their outputs, users demonstrate higher accuracy and lower subjective mental effort. The reason this is important is that opaque black box models subtly increase the cognitive load by requiring extra mental energy to interpret or question the AI's conclusions. Explainable AI offloads that burden by clarifying the why behind suggestions. And I can relate to this. I like to understand how things work. I don't like black box models too much. So the next finding is ethical design and bias mitigation. The finding is that AI perceived as biased or unfair leads users to invest more cognitive load resources in checking or circumventing those outputs, intensifying mental strain. The reason this is important is that distrust in AI fairness shifts mental bandwidth away from the core task and towards verifying correctness. Ethical bias aware design fosters trust and lowers user verification burden. The last finding is neurophysiological insights. The finding is that real-time brain imaging and physiological data confirm that specific design strategies measurably reduce mental strain. The reason this matters is that traditional user surveys capture subjective overload. Neuroimaging gives objective moment-to-moment data. This can guide interface tweaks that demonstrate and alleviate overload for mental activities. So in conclusion, we have that thoughtful AI design reduces rather than increases cognitive load. And for future direction, continue developing neuro-informed designs and investigate longitudinal user studies for deeper insight into trust ethics and user adaptation over time. Thank you.